Um, what is the which material does not exhibit the plastic region during tension? Whoever want know the answer kindly raise their hands.
Is it silica, madam?
I ask whoever already known the answer should raise their hand. I'll ask. Everyone find out the option raise, right? In that bar menu, yeah. Krishnan, do you able to find the option raise hand?
1 minute, madam. I
Anyone
think
else?
silica. Is it silica?
Yeah, I will ask you 1 minute. Anything else?
PET.
Okay. So first, Shanghamitra, right? So what is your answer?
PET.
PET. Why?
Because it is a polymer.
Okay. But the question does not exhibit a plastic region. Okay, fine. Next, Krishnan. And what is your
Yes,
answer?
madam.
Yes.
Silica, because it's ceramic, because ceramic material does not have any plastic region. So that's why I chose silica.
Okay. And Suranjana.
Silica.
Silica. Okay. The correct answer is silica. So, are you familiar with this graph?
Yes.
This is basically strain versus stress curve. Here you can find several points. So can anyone tell me at beyond which point the plastic region will present or plastic region will start?
C.
After yield point, madam. After yield point.
After which point?
Yield point. Yield point.
No, no. In that graph itself, there are certain points na A, B, C,
C,
D,
C,
E, F.
C, C point. C.
C.
Okay. So the correct answer is the C point. So can you tell me what is happened beyond the C, like before C point, from origin to C point?
RG to C point, it will be elastic. After that, it will behave like a plastic material. So deformation will happen.
No, in that
If
region,
till C
what?
point, it will come.
So from the graph itself, we can see up to point C, the stress or strain are directly proportional according to the Hooke's law. So what happened as the strain is increased, the stress is also increase. And if we remove the strain, it will come to its previous state. But after C point, if we remove the stress also, we cannot get back to our previous structure. So that's why beyond the C point, it's considered as a uh, plastic region. So there are stress versus strain graph for all the materials which were given in the option. So first we'll go to the PET. PET, what happened? PET has a very big region in the deformation region or in the plastic region. In the case of TC, it also has a plastic region because after the point A, if we put stress, it cannot get back to its actual state. In the case of silica, it's moreover like a straight line, which is touching to the origin or touching to the main zero. So what happen in this case? Stress is always perpendicular. Stress is always proportional to the strain. And what happened in the case of PVA? We also find a very big portion in the plastic region. So from there we can say silica is the material which does not exhibit a plastic region during tension. Now moving to the next question. If the force is if the force is applied in the x direction, Poisson ratio is given by. Anyone else? So Parani Kumar, can you please tell the answer? Why? Which is
Yeah,
your
here
answer?
x is force applied direction, which is a linear direction, and z we are taking, which is a lateral direction. So Ez by Ex will be the Poisson's ratio, and since it is in the opposite direction of the force applied, it will be minus Ez by Ex, which is option D.
Okay. Anyone else has any different answer? The correct option is Ez by Ex minus Ez by minus Ex. So what happened? Suppose we consider this Q and we put the force in the x direction. So uh, this is the z axis, this is the y axis. So usually when we put the force in the axial direction, the length will increase in the case of axial direction, and in the transverse direction, the length will decrease. So in that we can say axial stress is equal to sigma x, that is fx by a, that is fx by ab, and axial strain will be sigma x by e from there, and the transverse strain will be the minus, at it will be a negative. So the Poisson ratio will be minus Ez by Ex. So it will be by mistake. It is the current action is Ez by Ex. Now moving to the next question. A stent of length 11 millimeter and diameter of 7 millimeter has a 40 Newton force applied outward, producing an elongation of 0.01 millimeter. What is the stress acting on the material in Newton per millimeter square? I request all of you to solve this question, and whoever will get the answer, please raise their hand. I'll ask. So anyone able to solve this question? Um,
Yes.
yes. What is your answer?
Yeah, it is 1.039. So it's force by unit area. So area can be
Okay, I
calculated
will.
with the diameter.
Okay,
Yeah.
yeah. Okay. So anyone else able to solve the answer or solve the question? Okay. So as per the question, we find first we take the initial length of the stent, that is equal to L. So L is equals to 11 millimeter. We just rewriting the information in terms of numerical form, like in terms of problem. The diameter of the stent is mentioned as 7 am. So the radius will be r, that is 7 by 2, 3.5 millimeter. Then we found out the cross-sectional area of the stent, that is A equals to pi r square as per the formula of the circle. Then 38.46 mm square, that is pi into 3.5 whole square. Then as per the question, the force is given as 40 Newton. So force will be 40 Newton. The stress is come as 40 divided by 38.46, that is F by A. So that is come as 1.04 Newton per millimeter square, or 1.039 Newton per millimeter square. So has anyone have any doubt in this particular question? I ask everyone, whoever have any doubt, please ask right there itself. It will be help for you to understand the question as well.
What is the meaning of stent? Is it a wire?
Yeah, stent is basically some type of biomaterial because it's a part of your biomaterial course. So its stent is a part, it is a type of biomaterial which is used to put inside your heart. So I
Okay, ma'am.
think the what is stent is doesn't matter that much, but stent is a basically a biomaterial. Anyone have any doubt? Anyone have any further question? Okay, now moving to, should I move to the next question?
Yes, ma'am.
Yes.
A strength of the problem is more or less same. A strength of length 11 millimeter and diameter of 7 millimeter has 40 Newton force applied outward, producing an elongation of 0.01 millimeter. What is the strain? I the question is mentioned in that screen. Please solve the question. Am I audible?
Yes.
Yes, ma'am, you are audible.
Yes, ma'am.
Screen moving, right? Hello, Chaitanya. Okay, maybe I am not audible to him. Am I audible to him?
Yes, ma'am, you're audible.
Okay. No, I'm asking Chaitanya.
Yes, ma'am.
Okay, so are you able to see the question now?
No, ma'am, I'm getting the only presentation containing the first question.
Okay, you better just leave and again join.
Okay, ma'am.
Like, yeah. Okay, so Shankhamitra, can you please tell me what is the answer of this question?
9.09.
Okay. Anyone have 9.09?
It's 9.09 into 10 power minus 4. 0.01 by 11 is 9.09 10 power minus 4.
Yeah. So anyone have any different answer other than these two? Okay. So as per the question, the initial length of the stain, that is L, equals to 11 millimeter, which is mentioned in the question, and the elongation of length, that is small l or L.
0.0000909.
Whoever got the answer, please raise their hand. I will ask them. The elongation in length, that is delta L or the small l, will be 0.01 millimeter, and the strain will be delta L or small l divided by the capital L. So 0.01 divided by 11, that is 0.00000909, which is the correct answer. Now moving to the next question. A strength of length 11 millimeter and diameter of 7 millimeter has a 40 Newton force applied outwards, producing an elongation of 0.01 millimeter. What is the Young modulus of the material? Please solve the question by 7:45. Whoever, then I will tell. Okay, so the Adarsh Matthew, can you tell me what is the answer?
Ma'am, it is 1144.11 Newton per mm square.
Okay, Ketan Patel.
1143.12 Pascal or Newton per meter. Unit.
Okay, and Pranik.
Yeah, it's 1143 megapascal. Since it's a Newton per mm square, it will be megapascal.
Okay.
Yeah, sorry.
So, okay, so as per the question, the initial length of the strength is 11 millimeter, diameter of the strength is 7 millimeter, radius of the strength is 3.5, the cross sectional area is 38.46, force is 40 Newton, elongation of the length is 0.01 millimeter. So, as per the formula of Young modulus, y equals to FL by F into capital L divided by A into small l. So 40 into 11 divided by 38.46 into 0.01. The value is come as 1144.05 Newton per millimeter square. For this question, the range that is acceptable is around, I'm telling you, from 11:30 to 11:50. So whoever is got 11:43, that answer is also correct. Okay, so I'm moving to the next question. A stress of 2.5 megapascal is required to stretch at 1 centimeter tube to 1.1 centimeter. After 2 hours in the same stretch position, the strip exerts a stress of 1.5 megapascal. What is the stress relaxation time in hours? Others and Ketan, please put down your hands. Okay, so Parani Kumar, can you tell me the answer?
Yeah, here we can use a formula for sigma is equal to sigma naught exponential of minus t by tau naught. So where the sigma is stress at after 2 hours and sigma naught is the initial stress and t is time taken, that is 2 hours here. So tau naught will give you a value of stress relaxation time. So if you solve it, it come around 3.91 hours.
Okay. And others, what is your answer?
Ma'am, it's the same answer, 3.91 hours.
Okay. Okay. So as per the question, sigma naught is equal to 2.5 megapascal. That is the initial stress. Sigma equals to 1.5 megapascal. That is stress after 2 hours. And T equals to 2 hours. So we got to the formula sigma equals to sigma naught e to the power minus T by tau. Can anyone tell me what is the formula is this? What is the reaction name? What is this formula is called like? Okay, this is the task for everyone. Please solve please find out the name of this equation and let me know in the next class. So sigma, so we can solve it. We just keep sigma by sigma naught, that is come around e to the power minus t by tau. So ln of sigma by sigma naught, that is minus t by tau. So tau equals to is coming as minus t ln of sigma by sigma naught, and from there if you put the values come around 3.92. So the question is clear to all.
Yes.
Anyone have any doubt? Okay, so anyone have any doubt in this particular question? Should I move to the next question? A suture of trees is stretched with a tensile force. When the stress is relieved, it recovered 30% of its strain after 5 hours. What is the retardation time in hours? Okay, so please solve this question and let me know what is the answer. The slide is visible to all, right?
Yes, ma'am.
Okay, please solve this question. Hello? No one able to solve this question? Okay. Hello, Adarsh. Am I audible to you? What is the answer?
Ma'am, ma'am, it is 14.01 hours.
14 point?
14.01.
01. How do you solve it?
And we have taken the strain recovery equation, that is epsilon 0 into 1 minus e power t by lambda, where we
Okay.
can substitute strain recovery as 0.30, and we have taken epsilon 0 as 1 itself, then 1 minus e power minus 5 by lambda. So by solving lambda, we'll get at 14 hours.
Okay. And Parani, what is your answer?
Yeah, I also got the same answer. Same.
And how do you solve it?
Yeah, I just used since it is recovered by 30% of the strain. So initial I assumed it to be 1. So 0.3 is equal to 1 minus exponential of minus 5 by lambda. Since it's a 5 hours, I have used it. I have substituted 5. So if I solve these things, I got a 14.01.
Okay. Okay. Hello. As 1 minus e to the power t by tau, this part is considered as a function of elongation or retardation with respect to time. So now, if we consider 5 hours is our tradition time, so we put just 5 in all the places of t, so it's come as 1 point e to the power minus 5 by tau, that is equals to comes as 0.3. So when we're going to solve it, the tau is come as 14.045 or 14.045. So now moving to the next question. A switcher is stretched with a tensile force. When the stress is released, it recovers 30% of its strain after 5 hours. What is the amount of strain recovered after 7.5 hours of its original value? Please, Parani, put down your hand and please solve the question. Okay, so what is the correct answer of this question, Torani?
It is 0.4143. So since it's like same like a previous question, we can use the same lambda, which is 14.01. So the amount of strain will be equal to 1 minus exponential of minus, here it is 7.5 hertz. So 7.5 by 14. So if we solve this, we will get the amount of strain as 0.4143, which is 41.43%.
Okay. Anyone else is able to solve the question? Okay. So we use the same formula as the previous one, L minus L0 T, that is why L is the elongation, L0 is the initial length. So 1 minus e to the power minus t by tau. Here in this case, we go for 7.5 hours. So 7.5 hours and tau is come as 14.045. So 1 minus e to the power minus 7.5 divided by 14.045, that is come as 0.414 equals to 41.4%. Here L by L0 T should be equals to 7.5, not 6. So now moving to the next question. Dry bone contains 25% wet percentage and rest minerals and their corresponding modulus are 10 and 100 GPa respectively. Calculate the modulus of the bone using Ross model. Please solve the question and tell me the correct answer. Okay, Sanghamitra, what is the correct answer?
30.77.
Okay, and others?
Ma'am, it's the same, 30.769 gigapascal.
Okay, Purani Kumar?
Yeah, it's same answer. It's a lower bound value.
Okay, so anyone have any uh, uh, different answer on this particular question? So, Sanghamitra, how do you solve this question?
We have to substitute in the recess model for 1 by that 1 by V1 by E1 plus 1 by V2 plus E2. As the organic is 25, the mineral will be 75%. With substituting this, we have to get it.
Okay. So, here the rhesus model is 1 by E composite or the modulus of the composite is equal to M of the organic mass, the wet percentage of the organic material divided by the modulus of the organic material plus wet percentage of or the wet fraction of the inorganic material divided by in the modulus of the inorganic material. So wet fraction is comma 0.25 for organic fraction divided by modulus of the organic material is 10 as mentioned in the question. The plus 0.75 0.75 divided by 100, which is also come from the inorganic as mentioned in the question. The modulus of the inorganic material is 100 GPa. From there, the 1 by EC's value has come as 0.0325, that is come as 30.75 GPa. Now moving to the next question. The molecular weight of a biodegradable polymer decreases from 1 into 10 to the power 5 to 1 into 10 to the power 4 into 210 days in a first order manner. What will be its molecular weight after 450 days? Whoever is able to solve this question, please raise their hand. And is anyone able to solve this question? Okay. So for this, we going for the first order equation. So the first order equation is coming as ln A equals to ln A0 minus KT. It can be also says as A equals to A0 e to the power exponential to the power minus KT. From this is a simplify from after the simplification we got the k value that is equals to 1 by t ln of a0 by a. So we put the value 1 by 210 ln of 10 to the power 5 divided by 10 to the power 4. The value is come as 0.011. We put this rate constant value in the equation that is come as a equals to a0 e to the power minus kt. So a initial one is 10 to the power 5 into e to the power minus k value is 0.011 and the t value is come as 450. So the value is come as 708.34. Now moving to the next question. A wire of length of 2 meter and a cross-sectional area of 10 to the power 4 10 to the power minus 4 meters square is stretched by a load of 102 kg. The wire is stretched by 0.1 centimeter. Calculate the longitudinal stress, longitudinal strain, and Young modulus of the material of wire. Whoever is able to solve the question, please raise their hand. And all of you, please participate in that doubt solving session. It will be beneficial for you only. Can anyone tell me what is the longitudinal stress, longitudinal strain, and Young modulus of this material? Okay, so the initial length of the wire is L equals to 2 meter, cross sectional area 10 to the power minus 4 meter, stretching weight 102 kg weight, that is 102 into 9 to 9.8 Newton. Increase in length is 0.1 centimeter, that is 0.1 into 10 to the power minus 2 meter, because 10 to the power minus 3 meter equals to 9.8 meter per second square. Now moving to the first one, that is the stress. Stress equals to F by A. So F equals to 102.9 to 9.8 divided by A. A equals coming as divided by 10 to the power minus 4. So the stress value is coming around 1 into 10 to the power 7 Newton per 1 into 10 to the power 7 Newton per meter square. Now moving to the next one, that is strain. Strain is equal to 1 by L, that is 1 into 10 to the power minus 3 divided by 2, as 2 is given as the initial length. Now the Young modulus is come around y equals to stress divided by strain. The stress is come as 0.7 divided by strain. Strain is come around 5 into 10 to the power minus 4. The value is come as y is equal to 2 into 10 to the power minus 2 into 10 to the power 10 Newton per meter square. And so the stress is 1 into 10 to the power 7 Newton per meter square. Strain is 5 into 10 to the power minus 4. Young modulus of the material is y 2 minus 2 into 10 to the power 10 Newton per meter square. Now moving to the next question. A wire of 2 meter long and 2 millimeter in diameter, which stressed uh, by a weight of 8 kg has its length increased by 0.24 millimeter. Find the stress, strain, and the Young modulus of the material. Please solve the question and raise their hand. Okay, the initial length of the wire is 2 meter, diameter of the wire is 2 millimeter, radius of the wire is 2 divided by 2, that is 1 millimeter, that is 10 to the power minus 3 meter. Weight attached is M is equal to 2 kg. Increase in the length is 0.24 millimeter, that is 0.24 10 to the power minus 3 meter, which is equal to 9.8 meter per second square. Now moving to the formula stress, that is equal to F by A. Stress equals to 8 into 9.8 divided by 3.142 into 10 to the power minus 3. It is basically the pi r square. The stress is coming as 2.5 into 10 to the power 7 Newton per meter square. Strain is L, small l by capital L, that is come around 0.24 into 10 to the power minus 3 divided by 2, and the value is come around 1.2 into 10 to the power minus 4. Young modulus is 2.5 into 10 to the power stress divided by 5 to the power 7 divided by 1.2 into 10 to the power minus 4. So the y values come around 2.08 into 10 to the power 11 Newton per meter square. Now moving to the next question. A mild steel with a radius of 0.5 millimeter and length of 3 meter is stressed by a force of 49 Newton. Calculate the longitudinal stress, longitudinal strain, elongation period produced by the body if the y of the steel is 2.1 into 10 to the power 11 Newton per meter square. Did anyone solve this question? Please tell me the answer. Okay. So here the initial length of the wire is given as 3 meter. Radius of the wire is given as 0.5 millimeter. That is 0.5 into 10 to the power minus 3 meter, or 5 into 10 to the power 4 minus 14 to the power 4 meter. Force applied is 49 Newton. Young modulus is as 2.1 into 10 to the power 11 Newton per meter square. Now for stress is F by A, that is 49 divided by pi r square, though the r is given as 0.5 5 to the power 4 meter, so that we consider, then the stress values come out 6.238 10 to the power 7 Newton per meter square. Now y is equal to stress by strain. So stress by strain can be calculated as stress divided by y. So stress is come around 6.238 per 7 divided by the Newton, Young modulus values come around 2.1 into 10 per 11. So after calculating, the value is come around uh, so the strain value is come around 2.97 10 to the power 4. From strain we can calculate small l by capital L. So small l can be calculated as a strain into capital L. So strain is come around 2.970 and the capital L is come around 3 as mentioned in the question. So the small l is coming out 0.891 millimeter. So the stress is 6.238 into 10 to the power 7 Newton per meter square. Strain is 2.97 into 10 to the power 4 and the elongation is 0.891 millimeter. Now moving to the next question. Kindly solve this question and tell me the answer. Hello? Hello? Am I audible? Hello? Hello?
Yes, we can hear.
Yeah, so can you tell me, please, can anyone please solve this question and tell me what is the correct answer?
Stress it is 124.904 megapascal and strain it is 1.784 into 10 power minus 3 and the force constant I'm just still solving.
Okay, please solve it and let us know. Uh, So anyone able to find out the value of the force constant?
Yeah, since the length of the wire is 1 meter, force constant also will be the same like the force applied, which is 392.4 Newton. I think so. I'm not sure whether it is correct or not.
Okay. Anyone else have any different answer or anyone else able to solve it? Okay. So the correct answer of this is the initial length of the wire is L is equal to 1 meter. Diameter of the wire is 2 millimeter. So the radius is come around 1 millimeter. That is equal to 10 to the power minus 3 meter. Load attached to it is 40 kg and the Young modulus of the metal is 7 per 10 Newton per meter square. So as per the question, we first find out the stress. So stress is equal to F by A, that is equals to 40 into 9.8 divided by pi r square. Pi is 3 pi into r is will be the 10 to the power minus 3. So 10 to the power minus 3 whole square. So the value comes as 1.25 into 10 to the power 8 Newton per meter square. Now moving to the next one, that is Young modulus equals to stress divided by strain. So strain is equal to, you can calculate stress divided by y. So that is stress is find out as 1.25 10 to the power 8 divided by 7 into 10 to the power 10. So strain is comes as 1.78 divided into 10 to the power minus 3. So strain can be also written as small l divided by the capital L. So the elongation or extension can be calculated as strain into capital L. So 1.78 into 10 to the power minus 3, which is strain, into the length of the wire is 1. So 1. So the elongation is come around to 1.78 into 10 to the power 3 minus 3 meter. So now the force constant will be F divided by small l, that is force is 40 into 9.8 divided by the elongation, that is 1.78 into 10 to the power minus 3. So force constant is coming as 2.2 into 10 to the power 5 Newton per meter square. So this question is clear to all?
Yes, it's okay. Yeah.
Okay. So I'm moving to the next last question, that is, okay, a metal wire of length 1.5 meter and radius 0.4 millimeter is stretched by 1.2 millimeter on loading. If the Young modulus of its material is 12.5 into 10 to the power 10 Newton per meter square, find the stretching force.
Excuse me, ma'am.
Okay, Parani, so how do you solve this question?
They have given a Young's modulus, so we can find the strain by using the 1.2 mm as a change in length, and original length is 1.5 meter. So if we solve it, we will get a strain around 8 into 10 power minus 4. And with the help of a strain and Young's modulus, we can calculate the stress, which is 100 megapascal or 100 Newton per mm squared. And here the radius is given. So with the help of the radius, we can find the area, which came around 0.502. So now we know the area and we know the stress. So stress into area will give us the force. The force came around 50.26 Newton.
Okay. So the initial length of the wire is 1.5 meter. The radius of the wire is come around 0.4 mm, that is 0.4 into 10 to the power minus 3 meter, or 4 into 10 to the power minus 4 meter. Now the extension is given as 1.2 millimeter, that is 1 into 2, 1.2 10 to the power minus 3 meter, and the Young modulus is come around y equals to 12.5 into 10 to the power 10 Newton per meter square. Now we go for the formula of Young modulus, that is y equals to F into capital L divided by A into small l. So if we go F, the formula is equal to A into Young modulus into small l divided by the capital L. So A can be written as pi r square. If I put the value in the respective places, the F is come around 50.27 Newton. So the comes as 50.27 Newton. Okay. So, anyone have any doubt? Does anyone have any doubt? Okay. So, with that, we are concluding
Not,
today's
I have a
session.
single doubt, not for the regarding the problem, but generally about the course. So the
Yeah.
final exam for the course, will it be like a, objective type, or will it be like a theory written paper for the final exam? I am
No,
asking.
it's mostly the MCQ type, or is the numerical and the MCQ mixture.
Okay, okay. So it won't be a written type.
No,
It will
no.
be MCQ and numerical.
Yes.
Okay, fine.
Okay.
Yeah,
Have
thank you.
anyone has any doubt?
Ma'am, in this question, the
Yes.
length 1.5 meter is given. Do we need to change into millimeter before processing?
No, because we change everything in the meter, so length is keep it as 1.5 meter, because we change the radius of the wire is meter, extension in the meter, so length of the wire should be kept in meter only.
Okay.
Okay. And does anyone have any doubt? Okay, so with that we concluding today's session. Thank you all for joining.
Thank you, ma'am.
Thank you.